Students, welcome back. It is time to talk about lesson 2. We went over this a little bit. So the objectives, we're going to use the definition of exponential notation to make sense of the first law of exponents, which is multiplying exponents. We're going to see and simplify using division, and then we're going to write equivalent in some equivalent numerical and symbolic expressions, right? So the first law of exponents, multiplying. So I have the exponent here, 3 to the power 3 times 3 to the power 5. So I'm multiplying two exponents. I know 3 to the power 3 is 3 times 3 times 3, which is 27, and 3 to the power 5 is 3 times 3 times 3 times 3 times 3 times 3, which is 243, and I multiply them together, I get 6,561. So what? What if I didn't know what the 3 was? What if it was an x? Or what if the exponents were like 50 instead of 3 and 5? I couldn't even get that on my calculator. So let's learn how to do that with exponents. If 3 to the power 3 is 3 times 3 times 3, and 3 to the power 5 is 3 times 3 times 3 times 3 times 3, if I put all that together with the multiplication in the middle, so here's my first 3, here's my multiplication in the middle, and here's my last 5. How many 3's do I have all together? I have 8 of them. And I check that on my calculator. 3 times 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 3 is 6,561. Same answer. Can you explain why? Because 3 to the power 3 is 3 of them. 3 to the power 5 is 5 of them. And I'm multiplying all those together, so I'm multiplying 8 3's. Or 3 8 times is more precise. Don't make that mistake because it's easy to make. All right? Is there a shortcut to writing out all these 3's? Yes. Instead of writing out all the 3's and counting them, I can just say I'm adding the exponent, the power for each one. The power in my exponents. So my first exponent was 3, my second was 5. I add them together, and I got 8. This is the first law of exponents. Does it work for the same base? So think about it. If I do negative 3.4 5 times, and then negative 3.4 20 times, how many negative 3.4's do I have? I have 5 plus another 20. I have a total of 34. So negative 3.4 to the 5th power times negative 3.4 to the 29th power is negative 3.4 to the 34th power. Do you think this works with fractions? Of course it does. 2/3 to the 5th power is 2/3 times 2/3 times 2/3 times 2/3 times 2/3. And 2/3 to the 8th power is 2/3 times 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 2/3. Add all those together, I end up with 13 of them. What if I don't have a number? So x times x to the 4th. Well, how many x's do I have here? I have 1. And this is x times x times x times x. So I have x times x times x times x times x. How many x's do I have? I have 5 of them. So just think of when you have a base by itself, this x all by itself, then the exponent or the power is going to be the 1. So I can use the same formula when I'm multiplying two exponents with the same base. I just add the powers. So x times x to the 4th is x to the power of 1 plus 4, which is x to the 5th power. Okay? So in general, anytime I have a number x and a power m and n, and they're positive, then I can just add them together. X to the nth power times x to the nth power is x to the m plus the nth power. And my proof is x to the nth power is x times x times x m times, and x to the nth power is x times x times x n times, and I'm multiplying those together. So all of the x's that are being multiplied are m plus n x's. Got it? First rule of exponents, same base, add the powers together, you're done.